Today we are going to look about the construction of images in convex lens by ray diagrams. Alright, so let's look into the first case when the object is at infinity, but the rays are parallel to the principal axis like this. Alright, so the object is very far away at infinity, and these are the rays that are coming, and they are parallel to the principal axis. So we know how to draw the ray diagram now. All right, so first we draw two rays. The first one parallel to the principal axis will always pass through the focus. In this case, the second principal focus. This is the lens. This is our convex lens. All right, so after suffering refraction, it will pass through the first principal focus. Now this ray is also parallel to the principal axis. So after refraction, it will pass through the second principal axis. Alright, so there will be another rays also parallel to the principal axis, which after refraction, again the image will be formed at the second principal focus. This image is a real image. That means it can be formed on the screen. Alright, if the image is inverted, that is upside down. Whenever we have a real image, it is always inverted, and the image is very, very small, that is highly diminished, and it is formed at the principal focus. Now this principle, we see it in the case of a burning glass. When we take a magnifying glass and we put small pieces of paper and we allow the sunlight to fall on the magnifying glass, and we put pieces of paper here, we will see that these pieces of paper will start burning because the sun's rays are being focused at that point. This is the first case. The second case is when the object is at infinity, but the rays are not parallel to the principal axis. Here the rays are coming from infinity, but they are not parallel to the principal axis. Here we will see that after suffering refraction, the rays will fall at a point that is which is the focal plane. Focal plane is a plane which is at the second principal focus. These rays after refraction, will fall at a point here on the principal at the focal plane. So if I have another rays coming this side, alright, after refraction they are all going to fall at a point on the focal plane. Now the image here again is going to be real. It is going to be real, inverted and highly diminished. That is, it is going to be formed at the focal plane. The use of this is in the objective lens of the telescope. The third case is when the object is beyond. Now when I'm drawing this convex lens, when you see when I'm drawing this convex lens, I'm already drawn it beforehand, that this is the first principal focus, the second principal focus. There are two focus of a lens. Now this twice f1 is double the length of double the focal length. That is, from O to f1 is the focal length, then f1 to 2f1 is the same distance. It is twice the focal length. And here again I have f2, that is the second principal focus, and 2f2, that is from f2 to 2f2, the same distance as from O to f2. So this is the object which is beyond 2f1. We have got two rays to draw two rays. In order to find the position of the image, we are going to draw two rays. The first ray, which is drawn parallel to the principal axis, is drawn from the top of the object. Okay, this ray, after suffering refraction, will always pass through the principal focus. All right, then we have got the second ray will be drawn from the top and passing through the optical center. So if this is one, then the other one which is passing through the optical center, right, this is going to be the one passing through the optical center. All right, it's going to be, it will cross the other ray. Now one ray is parallel to the principal axis, it is passing through the focus, the second principal focus. Another ray passes through the optical center. They will cut the previous ray at the point in such a way that it is, we are going to get this image here, that is A dash, B dash. All right, this is between F2 and 2F2. Now this ray is again, this image is between F2 and 2F2. Now this image is real, inverted and diminished, and the use of this is in a photographic camera, that is a convex lens of a photographic camera. Now when the object, now the next part is when we bring the object from infinity, then we have seen that we have kept it beyond 2F1. Next it is going to be kept here at 2F1. Next it will be kept between 2F1 and F1. Next the object will be kept at F1. Then the object will be kept at between F1 and O. Now when the object is kept at 2F1, here you will see that this is the object AB. We have got two rays. One ray I am going to draw parallel to the principal focus. This ray is going to pass through the first principal to the second principal focus. Another ray which I am going to draw from the top, which will pass through the optical center. All right, I'm not going to draw so straight. Another ray which will pass through the optical center will cross the first ray in this point, and I can draw this image. A dash B dash is formed at 2F2. You will see that this image size is the same size as the size of the object. All right, though the image is real, inverted. All right, inverted means AB becomes A dash B dash upside down, but the size of the image is going to be the same. It is going to be formed at 2F2. This is used in a terrestrial telescope, all right, to see any object which is present in the land, all right, so that you can see the object is, the image is seen as the same size as the object size. Now the next case is when the object is between 2F1 and F1. That is between this case, that is 2F1 and F1. All right, the first, we are going to draw one ray parallel to the principal axis. This will pass through the second principal focus. Another ray from the top I'm going to draw through this. These two rays are cutting each other at this point, okay, and we are going to have a look at this. Going to go very far away. This I'm not going to have not drawn it so well. I'm going to just show this diagram. When the object is between 2F1 and F1, we are going to have this case, okay. The first ray parallel to the principal axis, it is passing through F2. Another one, which is another ray which I'm going to draw, passing through the optical center. These two rays are going to cross at a point which is beyond 2F2. This is A dash B dash. You will find that the image is going to be very enlarged, though it is real and inverted. This is A dash B dash. The image of AB, the image is real, it is inverted, right, but it is enlarged, and it is way beyond 2F2. This is used as in an optical projector. So here there is something which is wrong, which when I was drawing, it should have been right way beyond here. Okay, let me draw it properly later. Let me show you the case when the object is at F1. This is AB, the object is at F1. When I'm going to draw two rays here, one, I'm trying to focus the camera. The image of the ray after parallel to the principal axis after refraction will pass through to F1. Another one which is passing through O will also travel in this part. That is, after refraction, this is what is going to happen. Alright, and the one which is passing through O doesn't suffer any refraction, so we draw a straight line here. Now these two rays do not meet each other. This shows that the image is though real and inverted, but it is highly enlarged, that it is formed at infinity. And this is used in a searchlight when we have light falling through this lens. Okay, the light reaches up to infinity, so it is used in a searchlight. So the last case is when the object is between O and F1, that is between the optical center and the first principal focus. We are again going to draw two rays. This is the first ray parallel to the principal axis. After refraction, it will pass through the second principal focus. Every time it goes through this way. Another ray which passes through the optical center, you will find that it doesn't suffer any refraction. These two rays, we produce them backwards. Alright, these two rays, we produce them backwards. We will see that they meet at a point here. This point I call it as A dash, B dash. You find that it is on the same side of the lens as the object. So the image is formed on the same side of the lens as the object is present. Alright, so it is highly enlarged. It is now virtual image. It is erect. Alright, virtual erect and enlarged, and it is on the same side of the object. This is used in a simple microscope when the object is placed on and the image also you get on the same side of the lens. This is in the case of a simple microscope.